The motivation for this device is to create a wireless charging system for electric or autonomous vehicles equipped with an air gap actuation system and a foreign object detection system.
We achieve our air gap actuation system by using a DC gear motor to drive our scissor lift transmission, moving up our ground pad. And we achieve foreign object detection by using an array of IR transmitter and receiver pairs to detect if an object is in our vicinity.
We're now going to begin showing the state transition diagram from the initial point. So when I press the button to reset it, it'll go through the startup sequence, bringing it down to idle and bottom. The user will press this button to actuate it up, and it should go up to the top until it stalls, at which point it'll brake the motors and stay there. You can press it again to actuate it down, and it'll do the same thing. It'll wait till it stalls at the bottom. Now I'll press this again, and I can show the foreign object detection system. When I put my hand in the red zone, it should go down. Now I can show the desired behavior when this beam hits the roof or the bottom of your car, I suppose. When I press this down, it should disable the suite of sensors. So now I can put my hand here with no.
This rack and pinion and scissor lift mechanism is what enables our wireless charger platform to travel up and down. So this DC gear motor drives this pinion gear, and both of them, along with the entire crossbeam here, translate and rotate along this rack, which stays stationary. As this crossbeam translates back and forth, these pillow blocks get translated back and forth, which means this joint moves in this direction also. As this joint moves inward in this direction, the scissor lift moves upward, and that's what translates the top platform upward. We're really proud of how we're able to package this whole mechanism around the wireless charger transmitter module while encroaching minimally into its in space. So because this crossbeam travels back and forth, by the time this heatsink comes down to the base plate, near the base plate, the crossbeam will have already moved out of its way. So the crossbeam and the heatsink occupy the same space, just at different times. And this is how we're able to get this 250 millimeter or so wireless charger module in a overall platform that's only 360 millimeters wide.
The final part that we'll cover in our demonstration today is our structural heatsink. So with a wireless charger, we're producing quite a lot of loss, up to 20% of our power capability. So the way we address that is by having a structural heatsink that provides both rigidity and a thermal management system. We cool all these fins by having an axial fan array that sucks air in, pushes it through the fin array, and then out the vents on the side to ensure that we avoid recirculating hot air, keeping our entire wireless charger cool.